All right, everybody, welcome. It is 11:04. Hopefully the election results will be out soon. Today we'll be going over generics, and we'll also be going over Gradle and libraries. And I believe this will finish up our Java curriculum class. So this Friday for our meeting, I'm going to be opening more of a Q&A review session. So depending on what you guys want to go over, we'll go over it again, just like last time we did one. But generics is a complicated topic, and Grady, if you want to step in and say something, feel free to, because I'll be trying to go extra slow today when it comes to generics. So generics sounds like something that is kind of alien to programming. And basically, generics lets you have a class that handles multiple types. So I have two examples here. For example, if you're trying to deal with primitives, you can have a class handle integers, doubles, and floats, basically numbers, right? But in Java, they're all different types. And you can also have a class handle a car or a Ford or a Honda. They're all types of a vehicle, right? And uh, and again, if I were to define a car or a Ford or a Honda as a class for every single one of them, they would be a different type. A variable would be a different type. And so if you wanted to make a class that can handle integers, doubles, and floats, what you might do is make a interface, right? You'll make an interface, and then you'll implement that interface multiple times, each time handling for an integer, like defining a member variable as an integer, and then defining a member variable as a double, and another one as a float. And you have three different classes. And the same can go for the example of a car, a Ford, or a Honda. But the key thing is the reason why I say these are similar is because oftentimes when you are doing when you have to handle these multiple class types, you want to do actual stuff with them, right? Like for example, you want to do some operations or some conditionals or whatnot. But in general, you're going to be working with stuff that have a very similar type, and like they have a very similar data form, or you can perform the same actions on them. So for example, with all the numbers with integers, doubles, and floats, you can multiply them together. For a car and a Ford and a Honda, you can start an engine, right? And really the only times you're gonna have to deal with stuff that are not similar types is when you're doing a data class that just pretty much holds the value. And that's where generics come into play, because instead of having to make 3 or 4 or 5, I don't know how many different classes for every single individual type, you can just have one class, a generic class. So let's go and just take a look at the code example of what a generic is. So here I got a really simple generic, okay? I have a class called generics example, and you might notice here that I have a special notation here where I use these brackets and put the word T in it, and I close the brackets. It's convention to use the letter T. You're not required to use the letter T. Sometimes it's K, sometimes it's V, sometimes it's J, etc. But in general, if you're trying to make a generic, start with the letter T, okay? And you'll see here, you will see here that I have a member variable that is of type T, and then I have a constructor that takes in type T, obj, and then I assign it. Okay, so far this seems fine, right? Like this seems like familiar code. We just have a variable, we initialize it with a type, and in the constructor we give it a declaration, we give it a value, right? But the key difference here is, number one, we're specifying T in the class header, and also T is not an object type that I've defined yet. It's not an object type that is part of Java, right? Like Java has integers, floats, characters, strings. T is not one of them. It's something that we just set ourselves, but we also didn't make a class type of T. So what is T? T is basically any variable or any type that you can put in there. So a T in this code, right, can be an integer. A T can be a character, a char. A T can be a string. So basically, if you want to think of it differently, basically every single time you create a generics example and you pass in an object with type T, suddenly that generics example or that class, that instance is gonna become like an integer instance of generics example or a double instance of generics example. Okay, so as you can see here in this main function here, I've defined generics example my obj just like normal. If I wanted to make an instance, have a variable hold an instance of a class that I made, but then I have the curly brackets and I state what type t is going to be. So because I said integer here, when I try to declare my variable, when I initialize the variable, now this instance of generics example, t is now a type of integer, right? So it's kind of like a placeholder. T is kind of like a placeholder. And then to actually make the class, which is a new generics example, you still need the brackets, but because you already declared it in the variable, you don't have to put it here anymore. It's redundant. And then you can just pass in t obj. In this case, my object I'm passing is number 5, and number 5 will become type integer. So here I pass in an integer obj, and so obj is not equal to 5. And I have an instance of my obj. Does this sort of make sense to everybody right now? Kind of? Yeah. So I think it'll make more sense in my later examples. And Yash, you asked about the letter. No, the letter does not matter. So if I wanted to make this J, I just have to replace J for every single other kind, right? And it doesn't matter. So it's kind of like a variable name in a sense, except we're giving a name to a type.
I want to note that I think that T is pretty common because it is. And I think that I'm not exactly sure what that has to do with, maybe because the word type starts with a T, but T is definitely the most common thing you'll see there. Or it'll be like, we have an example in robot code where it'll be like the name of the thing that the object would take on, and that letter.
So we use generic so we can give obj different types like integer or string. Yeah, that's correct. So it has that flexibility that it can handle multiple different types. And we're going to go ahead and take a look at an example of that now. But first, just to kind of clarify, I have a class here. I've added a method to the class where I simply just say system.out.println obj.getClass. What obj.getClass is going to do is if I call it getClass method, and this is part of any object that exists in Java, you can call getClass on it. When you call getClass, it's going to return you the name of that class. For example, if it's an integer, it'll return java.lang.integer. If it is a string, I think it'll return java.lang.string. And if you do, if you try to run obj on, or if you try to run getClass on generics example, you're going to get generics example. That's going to be the result. So basically, it prints out the type of it. So we're going to do a small little practice here just to get you guys a little bit familiar with the deal with generics. I have two different generic objects here, okay? First one is my obj, and I pass in an integer 5. And I have my obj2, and I pass in a double for 3.0. And I call my obj.getType, which will print out the type of the first one, and my obj2.getType, which will print out the type of the second one. So what do you guys think the console will produce? Oh, right. Thank you for mentioning that. I forgot to mention here that I'm doing. You can also bound a generic. So remember in right, exactly. Yes, that's correct. So remember generics how all these ones I always mention a similar one. That's because we want to do similar operations on them. And the deal is we can do multiplication with integers, doubles, and floats, but you can't multiply a string, right? It doesn't make sense to multiply two strings together. Java's not going to know what to do with it. So what you have to do is you have to ensure that T, this type here, is going to be a number. It's going to be an integer or a float or a double. Okay, so you have to bound it to a certain set of types. And luckily, Java gives us the number type. And integer, double, float, they're all subclasses of number. So if we say T extends number, now when you initialize generics example, you can only pass in a class, or you can only pass in an object type that is number or number subclass. So because an example on the right, because integer is a subclass of number, we're allowed to do that. Because generic example double, or because double is a subclass of number, we're allowed to do that as well. But if we try to put in string, Java will give you a compile error and it won't let you run at all. And yeah, that's correct, Yash. And yeah, that's correct. Number is an inbuilt class given in Java. And in the same way, I'll talk about that later. So basically, this is the output you're going to get: class java.lang.integer and class java.lang.double. And now we're going to go ahead and lead into actually doing something with these object types. Because we bound them to number, that means we can do operations on them. So here I've added another method. It's called add. All right. And what this does, it extends, because T extends number. Number has a bunch of methods declared to it. For example, any number, you can say double value. It'll give you the double version of that value. Kind of like casting it to double, you know? Or you can say float value, or you can say integer value, right? And so what this add here is we're going to take the current objects, our member variables, double value, and then we're going to add the other object, which is a parameter. So we pass in another one, and it's going to add that, and then it's going to return it, okay? And you can see here, I can even use T as a parameter. So basically, because I initialized this instance here with integer, and T is now equal to integer, T here is going to expect an integer as a parameter. If I try to pass in a double, I'm pretty sure this would fail. Actually, let me just double check that right now. Yeah, that's correct. The compiler will complain. Okay. So what do you guys think? And I have a system out.println line that prints out the what dot add returns. What do you guys think will return? What do you guys think this will return? Yeah, that's right. 8. That's exactly what it says. So you can see how generics, now we have a class where we can handle both integers, doubles, and floats if we wanted to. And maybe even short or long, because that's technically part of number as well. And you can see here that as long as T shares the same methods, you can actually call the same methods on each other, right? And so this is why generics are really good when you're trying to handle multiple types of very similar data, right? Because you can call the shared methods and you can do a bunch of stuff with them. And remember, here, let me see if I can go all the way back. Let's go to, let's go ahead and find ArrayList, right? Remember when we initialized ArrayList and there was an integer? We had the same brackets with the integer. We're basically saying, because ArrayList is a generics class, so basically we're saying, hey, ArrayList, you're going to hold integer. And if you go into ArrayList code, and actually, you know what? Let's go and do that now. Let's go ahead and look at ArrayList code. That'll be a really good example. So if I were to say ArrayList, right? Okay. If I hold Control and then I click, this stands for IntelliJ, and I think it clicks as well. It'll bring you to where that class is defined. And you can see here, we have a generic type E, and then it has to extend another superclass, another generic class of type E. And let's go ahead and go into abstract list. And you can see here, abstract list extends abstract collection, and an abstract collection implements collection. So there's this whole hierarchy of generics, but that's beside the point. Basically, array list, you can pass in any E, and you can see here, if I scroll down, right? Remember a very common function we use with get list, right? Which is the method get. So let's go to the definition of that. So you can see here, get doesn't return an integer or a double. It returns E. Okay, because E is the type that it holds. And that's why array list can handle an integer, it can handle a string, it can handle a character, you know, it can handle another array list if you wanted it to. Okay, so that's what generics lets you do. Does this make sense to everybody? It's a little bit of a topic. Would array list be a place to use generics? Yeah. So every single time you use an array list or any sort of form of list, you are using a generic. It's a feature of Java that you will see very often. Does this make sense to everybody? Can you guys put the green check mark? If not, press X. Okay, cool. Let's go ahead and get back to the slides. Right, yeah. All right, so now we're going to talk about Gradle. Okay, so now we're going to get into a tool that really lets you use Java really powerfully and effectively. So far, we've just been playing with just really basic code by itself, but it wouldn't actually be any use in the real world. So when you create a new project, we usually go to new project Java, right? But instead, to start a Gradle project, in IntelliJ, you can create a Gradle project and already put in a bunch of the files that you already need to run Gradle, okay? And if you have the FRC plugin for IntelliJ and you directly make an FRC project, it will automatically put the Gradle files in there too for you. And basically what's going to do is it's going to generate what's called a Gradle wrapper. And the Gradle wrapper lets you run Gradle within that directory, within your project. So it's nice and contained. You don't have to install anything, I'm pretty sure, actually. And it will generate a gradlew.bat file and also just a normal gradlew file for those who are on Linux or Mac. And then you can run a bunch of those gradlew commands. Some of them are gradlew build, gradlew deploy, gradlew test, gradlew run. And basically, it's because Gradle, I think I put it in the wrong order. Yeah, Gradle is a build automation tool, and we use it for Java and Kotlin. And what that means, it helps package together Java, like all of your code. It helps compile it, and then it figures out a way to deliver it in a way that you want. Whether you want to package it up into an executable file that you can email to somebody and they can run the code on their computer, or in our case, run a command, have Gradle package it up, and then send it over to the Robo Rio on the robot, and the Robo Rio will run that code. Furthermore, Gradle lets us add libraries, meaning we can use other people's code in our own code, and we don't have to reinvent the wheel every single time we want to do something. For example, there's a bunch of like really useful classes out there that help you parse files, meaning like help you get file out of common file formats, help you process images, do some fancy math, deal with dates like March 3rd, how many days until March 3rd, or et cetera, et cetera. There's a lot of stuff that you can do with libraries that can really help aid your process. And we use them all the time as well. Even so, we have to use Gradle to add the libraries that we need to run our robot. So this is a really important tool. And so gradlew build will basically usually generate a jar file. It'll also run some tests and whatnot, make sure your code can build properly. Gradlew deploy is a little bit more specific, but when it comes to FRC projects, it means to deploy to the robot, send the code to the robot. Gradlew test is if you had a lot of test classes. That's something we didn't really cover and we don't do too often, but if you go into industry, you'll see it everywhere. But basically, Gradlew test will test your code based on what you told it to test, and Gradlew run just simply runs your code. And all this talk and no images and code is like really unhelpful. So I'm gonna go ahead and share my screen, and I will demonstrate to you guys how we create a Gradle project. So let me go ahead and just share my entire screen too. Right, you guys can see it, right? Great, you can see my like whole screen and whatnot, right?
I can see you're dragging an IntelliJ around.
Okay, cool. So what we're gonna do is we're gonna go ahead and create a new project. If you guys got IntelliJ right now, I would recommend you guys get your IntelliJ open. So tell me when you guys got your IntelliJ open, and then respond with the green check mark. I'll walk you guys through this process. And if you don't have IntelliJ, okay, you know what? We're all good. And Yash, you said you have it clipped, so it's okay. Just follow along. So we're gonna go ahead and go to File on the top left. You don't have to FRC building. That's fine. We're not doing that right now. We're gonna go to File on the top left, and we're gonna go to New, and then go ahead and press New Project. Okay, and tell me when you guys are here. I'll clear all. Great, we got Subra, Sunbreed. So I'm going to do it one more time for you guys. File, New, Project. All right, Samir. Okay, Samir's good. We're just waiting on Vinny now. Vinny, if you have any trouble, just ask us in the chat, okay? Okay, we're good. All right. Now, by default, it should be on Java, but on the left side, go in and select Gradle. And then you can see here that actually for Project SDK, you guys should be on 8 or 11. I'm on 11 right now. And then you can have Java, EAR, Groovy, blah, 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 Kotlin, all of this stuff. For now, just leave Java checkmarked, and we're not using Kotlin. So let's just do Java. So make sure only Java is checkmarked, and then go ahead and press Next. And then go to name this project whatever you want. I'm going to go ahead and just name this Gradle project. And then you can just go ahead and leave the location on its default. And you can press Finish. Okay. And then I recommend you guys, this pop-up will probably show up. It's asking you if you want to create a new window for this project or in this window. I'm just say this window. So tell me when you guys are done creating your project. Oh, we're just waiting on some read now. It says Java 14. It's okay. That probably means you have Java 14 installed. But we'll get you on the correct Java version if you decide to come to the robot code class. All right. So now we got our Gradle project, right? You'll notice that we have a few things that will show up. There's a few things to keep in mind. On the bottom right, there should be a little taskbar. If you guys don't have a super fast interconnection, it'll probably say downloading Gradle 6.5 or whatever. If you're already done, it's going to be running a bunch of stuff. And for me right now, you guys can go ahead and look at the Zoom. You guys can let IntelliJ do its own thing. You can see here how Gradle is starting a sync. Basically, when Gradle is syncing, it's going to read through the Gradle project files and then see, okay, is there anything new I have to update? Do I have to fetch any libraries, et cetera, et cetera. So right now, Gradle project is just building. It's starting the Gradle process, and it's going to be doing a lot of stuff in the background that will help your project work properly. Okay, you can see here, it says build successful. Right, and right now it's indexing dependencies, meaning IntelliJ is looking through and seeing if you have any libraries installed. And on the right side, there's a very useful panel for IntelliJ that will give you, which is right here, Gradle. Okay, and then tell me, can you guys do a green check mark if you guys have this tab and you guys are able to open it? Okay. All right, Wendy's good. Brendan, are you able to open this panel? You have to, okay, you have to use a slow MacBook. Okay. All right. It's okay, we'll go on ahead then. As long as you have the button there, I think you're fine. But basically the Gradle here, you can see here, you can press reload all Gradle projects. Now, admittedly, Gradle is sometimes a little bit finicky. Sometimes just randomly break on you. And you just have to tell it to, hey, can you please like manually, it's kind of like a manual refresh button, basically. If you click it, it's gonna run sync again, and it's gonna look through if you have any new dependencies. And then under the task folder, you can click it and you can see how we have build here, right? And build here, there's like jar and build and whatnot. And basically these are the Gradle tasks you can run. So you can double click them to run it. And you can see right now it's executing task build. It's calling some stuff, et cetera, et cetera. Okay. But basically this is where you can do your Gradle builds. It's not a drop down for me. That's likely because it's still downloading and refreshing, okay? But just know that when it's done downloading and refreshing and whatnot, syncing, it should eventually show up. We'll double check it towards the end of the class today. Okay, we'll make sure that you guys are all in the same place. So on the left, you guys all have a bunch of files that the project automatically created for you. Can you guys confirm if it's the same files as I do right now? Like do a yes or no. Okay. You have two Gradle folders, right? One is .gradle and one is just Gradle. It's okay. That's normal. Oh, it's okay if you don't have a build because I just ran the build thing. Okay. So just like, do you guys have most of the things in here? Most of the files, like it matches like 80% or so. Okay. Okay, I think we're good. And Vanit is a bit hanging right now. Vanit, are you having any issues with IntelliJ right now? Because you said you don't have a drop down for Gradle either. Oh, no, no, he's fine. All right, cool. So we're going to be doing the same thing here in source main Java, and this will be kind of familiar, right? We had a Java folder. This is where you're going to put your Java class. This is where your code goes. Resources is where you're going to put any extra files that you might read from it. But for now, we're going to ignore that. So we're going to go ahead and go to Java, and we're just going to go ahead and make an example package. Okay, and this is just to follow convention. We're just going to go ahead and do example com.example, and then go ahead and put your name. Like oh, actually, no. Sorry. Delete this. Let's go ahead and make a package just com that with your name. So mine is com.sam. Okay. And I'm going to go ahead and say new Java class. And then I'm going to go ahead and say, main. Oh, did someone just join? Oh, it's Daniel. Okay. We're going to go to make a class called main. Okay. So you should make a new package, com.samuel, and make a new Java class called main. All right. And we're going to go and just make a hello world. All right. Public static void main string. And can you guys do a green check mark when you guys have gotten here? Suvrov, you're getting an error. Class interface for enum expected. Okay. Okay. Suvrov, did you try to run a Gradle build? Just try to get the files to where we are right now. Make sure you're not missing any brackets or anything, and see if IntelliJ is telling you. Maybe Grady, can I put you and Suvrov in a breakout room?
Sure.
All right. I'll get Grady to help you out.
Sam,
Oh, never mind.
hold
Suvrov
on.
got it. Yeah. What's up, Grady?
Okay, never mind. But
Cool.
I'm gonna just change it so that all participants can share, so that when they get to breakout rooms, they still can.
Thank you. Okay. All right. So now we have a Java project that we're more or less familiar with, right? And in order to run Gradle, you can, if you're IntelliJ, you can always just right-click and you can run main. Or we're going to go in and use the terminal. So IntelliJ has a nice and simple terminal tab on the bottom. And if you're on Windows, you're going to run Gradle W dot bat, right? Or not dot, Gradle W dot bat. Okay, yes, I got it. You can run Gradle W dot bat, and then you can go ahead and run your Gradle. So Gradle W dot bat should work. You can see it's downloading and stuff. On Mac, so for Mac, you can just go and say /Gradle W and then put in the commands, okay? Wow. Yeah, Gradle likes to download a lot of stuff, especially when you're using a wrapper. Okay, you can see starting the Gradle daemon, I went on Java 14 support, blah, blah, blah. I'm gonna go to, if you want to stop, you can press Control C. That's kind of a general rule for terminals. Press Control C to cancel it. And instead of build, I'm gonna go ahead and run. And I'm pretty sure this will run the main function. Okay. No, it did not work. Task run was not found. Well, you told me Gradle was going to automatically make a run. You lied to me. Gradle is a library manager. Often downloads a lot of things. What part of it is? Okay, you know what? Just for now, if you want to run it, just do this. And you'll actually see IntelliJ will build, and I think it'll run the jar that it produces. Okay. Gradle choice. Let me just double check this real quick. If I just run build normally, it might actually just, I think you have to specify a main function in build. Let's see. Yeah. Okay. You know what? For now, if you want to run it, just go in and use what IntelliJ gives you because they know what to do. Anyways, when we're doing main.java, okay. So now we have a Java program. We can run it and whatnot, and et cetera, et cetera. So we can go ahead now and talk about libraries for a bit. Okay. And we're going to talk about library use. Basically, in order to add the library to Gradle, we have to go to a main repository, and then you can usually have a line of Gradle they can copy. You'll add it to your build.gradle file, and there's a dependency section in there. And then when you run Gradle build or Gradle sync, you can go ahead and import that library into your code, and you can use it however you want. And so basically, step 1, import. Step 2, usually you initialize the class from the library. Step 3, use the class from the library. Okay, and you can type out the name of the class, and IntelliJ will also auto-import it usually for you. And then Googling is a really powerful tool when you're working with libraries. So I'm going to go ahead and talk through the step-by-step process of doing it, and I'm going to talk about how, well, at least I look for libraries that will help me write code. So, for example, let's say, for me personally, I absolutely hate handling. I really dislike handling dates. I find dealing the numbers and whatnot to be really confusing. So let's go ahead and start off as to how I would probably end up looking for a library. So I need a Java library that handles dates, right? And I think you guys should all open Google and try to follow this along because it's a process. Okay, so we're gonna go ahead and search Java date library. Okay, we're gonna go and search Java date library. And okay, Java already has a date class. All right, you know what, we're gonna use Joda then. All right, let's say that a Java date library is not enough for us. Okay, and we see, okay, there's this thing called Joda time. They seem to give you local date, local time, instant, date time zone, etc. So can you guys find this website? If you guys Google Java date library, okay, Java date library, you guys should be able to find it, right? Do the green check mark if you guys can find it on Google. Okay, most people have found it. Okay, cool. Everyone's found it. All right. So on the Joda Time website, if I scroll down, and most websites, most libraries that have an individual website of their own will show how to add it. We can see here releases, right? They say blah 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 is the current release, and then they have this looking code. this interesting looking code. This is for Maven. It's more of an outdated project manager, but we're using Gradle, so this doesn't apply to us. So you can see here they've given us a link to Maven Central. We can go click it and it'll send us to Maven Central, or, and this is usually how I do it. I just search Maven Central and I say Joda, okay, Joda time, because that's the name of the library. And usually the top link will send me to mavenrepository.com or some other similar one. And then here I can go ahead and select the version. Okay, so I'm just going to choose the latest one. And you can see here, I've got the Maven code, which looks very similar to what Joda time gave me here, right? And then I can go to the Gradle tab and it'll give you this code. Okay. Tell me, do a check mark if you guys are able to find this website and find this information. So remember, just you can go in and search up like Maven Central or Gradle Joda time. Okay. Actually, it's probably better to search Maven because you can just get Maven repository. All right, so far only Brendan and Sandra have been able to find it, I assume. Can you just put the link in the chat? All right. I just want you guys to practice looking up how to do it. Okay. I just DM'd it to Grady. There you go. All right. Well, okay. Most people seem to have found it. Okay. So go ahead and copy and paste this code. All right. When you click on it, actually auto select and copy it for you. And then when you do, let's go to your build.gradle file in your project. And you can see there's a section here called dependencies, and you might have noticed it's a test compile line. Go ahead and put whatever it told you after that. Okay. And when you're done, just go ahead and press the circle button. Did I remember to clear? I think I forgot.
Quick note to everyone. So when you're copying the lines from Gradle, so when you're copying this line like compile, group, blah, 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 make sure to always replace compile with implementation. Compile is rather outdated at this point, and they've replaced it with implementation as a completely separate thing. Usually it won't cause problems, but just remember to replace it.
Yeah, so newer versions of Gradle is using implementation instead of compile. Basically, a lot of the things you get from here are from compile. So when you copy and paste into your build.gradle file, and sorry, I hope you can get that. Go ahead and just directly replace it with implementation. Your code should run fine, and it'll be future-proof for when you upgrade. Okay,
Yes,
everyone. Oh, sorry.
Yeah, so for example, in the code that's currently on screen, test compile, you would want to replace it with test implementation.
Give me a check mark when you guys have gotten here and copy pasted the Joda time thing. Oh, yeah. After you guys have copy and pasted this in, on the Gradle tab on the right, like what I showed you guys, remember, click up here, go in and click the reload all Gradle projects button. Okay, and that will make sure that it'll download dependencies, and then your thing should become like not gray anymore. Put a check mark, please, when you guys are done, so we may move on. Let's take a look at the presidential election. Ooh, interesting. All right. Is everyone able to get here? Okay, we have more people. All right, Brennan, Brittany, we're just waiting on you now. All right. Okay, cool. We're gonna go ahead and move on now. Let's go ahead and use this project. Okay, so let's go and quick look at Joda time real quick. Let's see, local date, date without time. All right, let's go and just try that out then. All right. So we're gonna just assume if I type local date, you can see here I have java.time. I also have org.joda.time. When I start typing out the name of the class, it'll show it for me. And if I select org.joda.time, press enter, you'll see it automatically imports for me. If I don't have this import sign, you can always just hover over it. And you can press Alt Enter if you're using the Eclipse key Mac, of course. And you can import the class automatically and choose Joda time. All right, and I'm gonna say my date is equal to new local date, and this is probably how you use it. Okay, and now system.out.print line my date. Let's see what it prints out. So I'm gonna right click, run down main.main. Oh, right here. You can see it prints out today's date, 2020 1104. And so we have now successfully imported, we have added a library to Grady. We have imported into our Gradle project, we have imported into our Java code, and now we run code using that library. Cool, right? So if you guys can get this to work, go ahead and give me a green check mark. All right, looks like most people have been able to do it now. Just give you some stuff after the date. Oh, just give me the time. Never mind. If you right. Okay, we got Samir now, and we're just waiting on Vinny. Okay. So far we have so far this whole process makes sense to you guys, like being able to look for libraries and use the libraries in your own code. Does this make sense? Yes, no? I've got one yes. Okay, so yeah, that's pretty much library use with Gradle. Let me think. Is there anything else we should talk about, really, about library use? We have 10 extra minutes. Okay. I was originally thinking of doing GitHub when we do robot code, but okay. Tell me in the chat, would you guys be interested in just trying to like at least like make a GitHub account and whatnot?
Might as well do that now.
Yeah. All right, Brenda's already got one. Does anyone not have a GitHub account?
Just go demonstrate how to make a GitHub account, and then you guys can put your username in the chat.
Yeah, and Grady should be able to add you to our team, right? So
if you would like me to do that, I can do that.
That would be very nice. So, if you guys aren't already aware of what GitHub is a repository manager sort of thing. Okay, GitHub hosts repositories, like their underlying technology. And basically what GitHub allows us to do is it lets us share and manage code, lets us review other people's code, and gives us is like a really nice way to develop as a whole team. Okay. So let's go ahead and sign up for GitHub, put in a username you like, put in your email and your password. It's just like normal, and go ahead and sign up for GitHub. All right. And when you guys are done, go ahead and put your username, and because it will let us add you to our plastic robotics team. And then we can go ahead and give you guys access to our repositories and whatnot. So Brendan's already got Brendan has already got his username, so that's good. Okay, we got Sambri. Sambri's got a username. Oh, that's a good idea. Yeah. If you guys can you guys put your GitHub usernames in the Slack? Okay. So like if you look at my screen right now, we're just gonna reply to the learning agenda, and I'm gonna
Actually,
go
yeah, can you guys put it in Slack? Because I said to put it in the chat, but I can't copy and paste from the chat. So Slack would be a much better place to put it. But Brendan, I just invited you.
Yeah. So after Grady invites you guys, go ahead and check your email. Apparently, Sid Banerjee is developing C#, and Maharishi is a grape. That was back in June, though. So. All right, thank you, Wendy. Do we? I would recommend you guys all use your personal ID for GitHub, especially since I'm pretty sure you can't make a GitHub account with your school email, simply because the school doesn't allow you to receive messages that are not from CUHSD, which is kind of annoying, but I can also understand why. But so be it.
Yeah, and also try to use your personal email. You won't be using GitHub for like just the robotics club. If you plan on doing programming in the future, your GitHub account will be very useful to you, so you'll want it on your personal.
Give me a check mark when you guys have created a GitHub account and /or posted your username on Slack. For those who are done, I'm gonna go ahead and send you guys a link for Git. Yeah, just do the free plan, Yash. Go ahead and just go ahead and download Git if you're done already, and then just press. If you're on Windows, just download the latest release. If you're on Mac, so on and so forth. And you don't have to adjust any of the settings. Just leave it on default. Oh man, it's been an interesting 2 months teaching Java, I tell you. All right, well, basically, yeah. Go ahead and make a GitHub account. Yeah, go and install Git. Yeah, install the CLI. That's right. Go and just install Git. Okay, we got Yash now. So yeah, go in and make a GitHub account, push it on Slack, and then go in and install Git. And then I think that will be it for today's class, just because we had 10 minutes of filler time. Oh, actually, that's a good idea. I forgot that not everyone actually uses a command line like me. If you can, you guys should also install GitHub Desktop. Why am I DMing you to Grady? Go ahead and install GitHub Desktop as well. So these are just programs that will help you use Git a lot. Actually, I need to install GitHub Desktop too. All right, you're good then, Vinny.
So I think you guys are fine to go if you're done with all three of those things.
Yep, pretty much.
So, how many of you are in this call? One.
We have 7
two.
people, and we have 7 usernames now.
Oh, I
so-
just got Samir.
Right. Cool. If you guys are done with creating a GitHub account, installing Git, or downloading Git and installing Git, and downloading and installing GitHub Desktop, you guys are free to go. Thanks for
So
coming
now
to
it's
today's
just
session.
so I've invited all of you, I think. Oh, I missed Suvra.
All right.
Okay, so I've invited all you. 4 you still haven't accepted your invitation. Please do that. But
And then the senior software members will stay, and if you guys need help downloading or looking for it. All right, I gotta start looking to the FRC simulation stuff, and I can't be lazy.
Hold on, Wendy.
GitHub Desktop gives you a really nice and clean GUI that will help you manage your Git repo. It's like, because previously the tradition for GitHub is to use the command line completely just by itself. GitHub Desktop has existed for several years now. They've been developing it, and it's become like, I think it's a very good way to do it, especially if you're new to Git and you don't want to learn the command line. It's just better for you guys. Wait, in Robot Code, do we use Java GUIs? No, we don't, Yash. Thank goodness, that would add a lot of extra bloat to our code. All right. Yep, that's right. Bye-bye, Sivrov. Thank you. All right, just Samir and Wendy now. All right, bye-bye, Yash. Cool, Samir. You're free to go. Thank you for coming. Bye-bye. All right, I'm gonna end the meeting now too, okay?
Okay.
See you
Thanks
guys.
for coming and like explaining stuff for me.
All right.
Bye-bye.
Bye-bye.